Hey, Hassler here. I'm going to work through the 1.4 Explore. This is the activity that we did in our groups at the board. And so we're looking at patterns, and we're going to see if we can write some rule to describe how to find, in this case, how many squares would be, in the 10th figure or the 100th figure. So let's take a look. Anytime I have a picture, I realize that I'm probably going to have to count something. And so one says determine the number of small squares that make up each figure. So I'm going to have to count the number of squares. And when I have to count, I like to label. So in this first picture, there are 2 squares. And in the second picture, I have 6. And in the next picture, I have 12. And then in the next picture, I have 20. And so down here, I have to fill out this table for the figure number. In the first figure, I had 2, 6, 12, 20. And it says, how do you see the pattern growing? And so there are a couple ways that we can see how this pattern grows. And one way to see the way the pattern grows is to say, hey, what's happening from one picture to the next? And it looks like from the first figure to the second, I added 4. And then it looks like I added 6. And then it looks like I added 8. And so I could write this, and we have to be careful how we write it. I'm not going up by 2. I am adding 2 more than the previous. I'm adding 2 more than the previous amount each time. So that's one way to talk about that pattern. I'm going to come back to this. Let's first go back and answer then 3. Is to sketch or describe what figure 5 would look like. How many squares will it have? All right, so if I were to sketch this, how would I know how many squares I should have? Well, one way I could know is I could go back up here to my table and say, hey, I'm adding 2 more than I previously added. So from figure 3 to 4, I added 8, which means from figure 4 to figure 5, I should add 10. So 20 plus 10 would give me 30 little squares in figure 5. So I think there should be 30. But there is another way I could look at this pattern. So I'm going to go back up here to this picture. When I started rattling off how many squares were in each picture, I was actually doing some quick math. I was multiplying 1 times 2 to get 2. And I said, hey, there's 2 rows here. Remember, a row goes this way. And there were 3 columns here. 1, 2, 3 columns. And so I was doing 2 times 3, that's 6. And so there were 3 rows here, and there are 4 columns here, and 3 times 4 is 12. And there are 4 rows here, and there were 5 columns, and 4 times 5 is 20. And so I was just doing some quick multiplication in order to figure out really that area, that square area. But when doing that, I also happened to notice that however many rows there were, that matched the figure number. So like here in figure 2, there were 2 rows. That was figure 2. And figure 3 had 3 rows. And figure 4 had 4 rows. So I'm guessing if I come back down here and make my picture, the figure 5 is going to have 5 rows. 1, 2, 3, 4, 5. The other thing that I notice is that however many rows there are, I had an extra column. So 1 row, but 2 columns. 2 rows, but 3 columns. 3 rows, but 4 columns. 4 rows, but 5 columns. So I'm really looking to, recognize any patterns that I can. And so that means that if I had 5 rows, then I should probably have 6 columns. There we go, 6 columns. And so really when I do count this, I end up doing 5 times 6, which is 30. So a couple ways to think about these patterns here. It says, is there a faster way to determine the number of squares besides counting them one by one? Yeah, it's this multiplication, right? I'm going to take this length times width of this rectangle, length times width to find the area of that rectangle. That's a faster way, I think, than, counting them up individually. And keeping in mind with this pattern, it says describe what figure 38 would look like. How many small squares would be in figure 38? And I want to go back to this idea. Oops, I want to go back to this idea here. If I were to draw figure 38, there'd probably be a lot of squares. But I have 30 squares for figure 5. So if I'm at figure 38, it's going to be a lot more. We said whatever the figure number is matches my number of rows. So in this case, if I'm at figure 38, I would have 38 rows. And back in problem 3, we said if there's 5 rows, there's one more column. So for figure 38, if there are 38 rows, I have 39 columns. In part 4 said I can just go ahead and multiply those together in order to find that number more quickly. When I do that, I get 1482. So 6 says, hey, how many squares will I find in figure n? As in like, hey, if I were to come back up and extend this table, ... what would that look like for figure n? I should have some sort of formula to help me use that. So I'm going to go back and I'm going to kind of, reorient myself. We said that in figure 1, we had 1 row times 2 columns. And we said in figure 2, we had 2 rows and 3 columns. And we said in figure 3, we had 3 rows and 4 columns. So what would figure n look like? Well, again, whatever my figure number was, that showed up in my multiplying. So if I'm looking at figure n just means that I could put any number in there, right? Figure 50, figure 100, figure 1,000. Whatever this number is, I would have to use that number times. And we said that the second number is always 1 more than that figure given. So 3 is 1 more than 2, and 4 is 1 more than 3. So I need to say whatever that number is and 1 more than that. And this would be that formula. So I know that you might be sitting there thinking, wow, I don't know, I could get that on my own. And we understand. And that's why we're here to help you recognize some patterns. And I think the more we describe these patterns verbally or think about what patterns are happening and talk with our teams, we'll be able to recognize patterns more easily the more we work through them. But if you have questions, don't hesitate to ask your teacher.